Good morning, students. Today we are going to discuss about the third chapter from chemistry, that is metals and non-metals. Okay, so already we have covered few of the topics and today we are going to discuss chemical properties of chemical properties of non-metals. What we are going to discuss today? Chemical properties of non-metals. So here first one is reaction with oxygen. What we are going to discuss today? First one is reaction of non-metals with oxygen. So when any non-metal react with oxygen, you know what we will get? That corresponding oxides we will get. What we will get? Corresponding oxides we will get. These oxides, some are acidic in nature and some are neutral in nature. Clear? So if we will see the example, carbon is a non-metal, na? So when carbon react with oxygen, it will form carbon dioxide. After this is acidic in nature. This is acidic oxide. Carbon dioxide is acidic oxide. Means when carbon dioxide gas we are mixing with water. Okay, we are mixing with water. We will get carbonic acid. What we will get? Carbonic acid. Carbonic acid means when you are taking this solution, you just keep blue litmus paper in that one. If you are keeping blue means automatically it changes to red. Nothing but blue color is changing to red means which nature it will have, acidic nature or not. So that's why we will tell that carbon dioxide is a acidic oxide. Clear? So second, one more example, if you will take sulfur plus oxygen, they will give sulfur dioxide. Same here also, if you are mixing that sulfur dioxide gas with water, you will get sulfurous acid. What you will get? Sulfurous acid you will get. Same here also, if you are clipping blue litmus there, it will change into red color. So by that we can tell that this is also which oxide? Acidic oxide. Sulfur dioxide is also acidic oxide. Okay children, and these are some of the examples of acidic oxide. Then if we will come to neutral oxides, carbon monoxide is one neutral oxide. See, carbon is a non-metal oxide, carbon monoxide. Even dinitrogen monoxide is also one neutral oxide. Even nitrogen monoxide is also one neutral oxide. Even H2O, our water is a hydrogen is a non-metal or not? It is a oxide, non-metal oxide. So water is also a oxide which is neutral means no, not acidic, not basic. Okay, so if we'll see some reactions, okay, if we'll see the reactions like with carbon, means how they'll form, what type of neutral oxides will form now when carbon reacts with oxygen. Okay, carbon monoxide will be forming here if we'll balance na this one. Clear children? So when carbon burns in insufficient air, okay, when this carbon burns in insufficient of air na, then only carbon monoxide will be formed. If we are supplying sufficient amount of oxygen, carbon dioxide will be formed. If we are supplying insufficient amount of oxygen, in that case only carbon monoxide will be forming, which is neutral oxide. Even when hydrogen reacts with oxygen, we know what we will get? Water is also nothing but oxide, but neutral oxide. Clear children? So this is of the reaction of non-metals with oxygen. Okay, so second one is reaction of non-metals with water. Reaction of non-metals with water. Do you think non-metals will react with water? No, the non-metals will not react. Non-metals plus water, they will not react. No reaction. Why? Because non-metals cannot give electrons. Okay, non-metals cannot give electrons. To reduce H2O means nothing but H plus plus OH minus or not. Okay, so here to change this H plus into H2 gas, it requires some electrons, isn't it or not? So non-metals are not donators. Non-metals are acceptors of electrons. They cannot donate electrons. They are always ready to take the electron. So they are unable to give electrons to reduce this hydrogen ion into hydrogen gas. So finally there will be no reaction between non-metals and water. Okay, so there will be no reaction. And third one also, reaction of non-metals with dilute acids. Dilute acids. So here non-metals plus dilute acids. Okay, HCl. So here also there will be no reaction. Here also there will be no reaction. Same reason here also, if we will see now, non-metals are unable to displace hydrogen. H means here also nothing but H plus plus Cl minus or not. To reduce this H plus into H2 gas, they require some electrons from this non-metal or not, isn't it? But non-metals cannot give, or they are unable to give electrons. They are always ready to take electrons. They will look here and there. If anybody will give electrons, we will take like that. So they are unable to give electrons to hydrogen ion. So finally the hydrogen gas is unable to produce in that case. Clear? So because of this reason, there will be no reaction between non-metals and any acid, not only HCl, dilute acid. So if we will see now, non-metals are not able to displace hydrogen from acids. So in order to displace these hydrogen ions and convert them into H2 gas, electron should be supplied. Okay, being a non-metal, it is an acceptor of electron. Okay, so cannot give electrons to the hydrogen ions here of the acid to reduce them to hydrogen gas. So non-metals are unable to displace hydrogen ions from acids to form hydrogen gas. So that's why there will be no reaction between non-metals and dilute acids. Clear, children? So this is of reaction of non-metals with acids. Then if we will go to fourth one. Okay, fourth reaction, that is reaction of non-metals. Reaction of non-metals with salt solutions. Salt solutions. So here if we will see a more reactive non-metal. Okay, more reactive. Already you know displacement. More reactive non-metal can displace. Which one? Less reactive non-metal. Less reactive non-metal. So for example, if we will see sodium bromide, if you are taking sodium bromide, we will react with chlorine. See, concentrate, this is bromine, non-metal. This is also non-metal. This is what? Sodium bromide. This is, you know, chlorine. Okay. So when they'll react with you will get NaCl plus bromine. Okay. So in this reaction, what happens? A more reactive non-metal, which is more reactive here. Chlorine is more reactive than bromine. So this chlorine displaces bromine and send that bromine outside. Clear? So here what happens? A more reactive non-metal can displace the less reactive non-metal, like displacement. Okay. Then fifth one is reaction of non-metals with chlorine. Reaction of non-metals with chlorine. Here when non-metals react with chlorine, they form, okay, non-metals, when they react with chlorine, they form covalent chlorides. Covalent chlorides means, for example, non-metal H2 I am taking, chlorine I am taking. So finally we will get 2HCl. 2HCl, actually its name is hydrogen chloride. Hydrogen chloride, it is a covalent chloride. Covalent chloride means generally they will be forming by sharing of electrons. By sharing of electrons. Here hydrogen will not give electrons to chlorine and chlorine also will not give electrons to chlorine. They will share their electrons, and covalent means by sharing. Okay, by sharing the electrons whatever they have now, so they will form corresponding chlorides. They will not have ions. Okay, they will not have ions. Since they are unable to have ions, they are non-electrolytes. They are non-electrolytes. Non-electrolytes means unable to conduct. They do not conduct electricity. Why? Because ions will not be there here. They will be forming whatever chlorides are forming. They are forming by the sharing of electrons. Okay, that's why they are unable to conduct the electricity. They are non-electrolytes. Even if you will see with phosphorus, okay, sorry, phosphorus P4 plus chlorine. When phosphorus react with chlorine, what you will get? Phosphorus trichloride you will get. You will get phosphorus trichloride. It is also a non-electrolyte. Okay, non-electrolyte. If you will balance na this one, P4 plus 6Cl2, you will get 4PCl3. Clear, children? So this is the reaction of non-metals with chlorine. And if you will go to sixth one, na, reaction of non-metals. Okay, reaction of non-metals. Here also reaction of non-metals with hydrogen. Here reaction of non-metals with hydrogen. So we will see here also, when non-metals react with hydrogen, they form covalent hydrates. Covalent hydrates. So if you will see the example, H2 plus sulfur. So here sulfur is non-metal. So you will get finally H2S. Its name is hydrogen sulfide. What is its name? Hydrogen sulfide. So when any non-metal reacts with hydrogen, they form covalent hydrates. Here also they will not, hydrogen will not give, or sulfur also will not give, or they will not accept. They will form hydrates by sharing of their electrons. How they will form? By sharing of their electrons. So like that, here the reaction happens between hydrogen and sulfur. Even if you will see nitrogen, okay, and even reacting with hydrogen, so finally you will get ammonia. What you will get? Ammonia. Here 3. If you are balancing, here you will get 2. NH3, general name is ammonia. Ammonia is also a covalent hydrate. Means here nitrogen and hydrogen will share their electrons with each other. Okay, by sharing, when they are sharing, there will be no ions. So they cannot conduct the electricity. Clear here, children? So like this, there will be a reaction between non-metals and hydrogen. And if you will see some more, even water is also a hydride of, means when oxygen combines with, oxygen is a non-metal or not? Yes. When it combines with hydrogen, then only we are getting water or not? Yes. So even methane means when the carbon is reacting with hydrogen. When the carbon is reacting with hydrogen, then only we are getting methane. So it is also hydride of carbon or not? So like that, when non-metals react with hydrogen, corresponding hydrates will form, which are covalent in nature. Covalent hydrates. So all those are clear, children. Actually non-metals form covalent hydrates. Non-metal form covalent hydrates because non-metals cannot give electrons to hydrogen atoms to form hydride ions. Okay, so non-metals generally, they are which state? They are generally in either liquid state or gaseous state. Okay, non-metals, as they do not contain any ions, they are unable to conduct the electricity. Clear, children? So these are the chemical properties of non-metals. What they are? Chemical properties, if we will see, first one is reaction with oxygen, reaction of non-metals with oxygen. So they will either maybe acidic or neutral oxides. We will get some acidic oxides also we have seen, some neutral oxides also we have seen. And second one, reaction with water. There will be no reaction with water of non-metals. And reaction with dilute acids also, there will be no reaction of non-metals with dilute acids, because non-metals are unable to give electrons to reduce the hydrogen ions of the acid to hydrogen gas. That's why there will be no reaction. Even reaction with salt solutions means more reactive non-metal can displace the less reactive non-metal. Nothing but displacement. So next one, reaction of non-metals with chlorine and no reaction of non-metals with hydrogen. Here covalent chlorides will be forming. Here covalent hydrates will be formed. These are non-electrolytes. Chlorides also non-electrolytes, covalent hydrates also non-electrolytes. Since they do not contain any ions, they are unable to conduct the electrons. So these are the 6 chemical properties. Okay, 6 chemical properties of non-metal. So children, up to here make the notes, read the textbook thoroughly. Okay children, thank you.